I'm Maria Drăgulinescu. I'm a member of AI Multimedia Lab. And together with my sender and host supervisors, Bogdan Ionescu and Lucil Tasateli and Ramona Parisu Pardo, I work on my exchange on machine learning assisted operational research algorithms for multimedia network control. I must confess from the beginning that I have signed also a confidentiality agreement. So let's say my presentation is maybe more general and more focused on the objectives and the outcomes of the exchange. So in the next minutes, I will talk also about the activities and tasks I had to perform in order to reach our goals. And also I will target some specific results, and mainly my presentation is built up on the template sections in the of the document we have to send on the report. So concerning the motivation behind the exchange, in general, concerning the multimedia applications, the content distribution is done via high-speed mobile networks, where we have to meet some high quality of experience requirements. And also we have to reduce the resource costs, and here I refer to storing, transcoding, and routing. Also, we know that the multimedia contents have many features that impact the resource allocation mechanism. And also, there is a need for content-centric AI algorithms and applications that are also addressed by AI for Media project. Moreover, the video content is far more richer in features, and this thing makes the resource allocation very challenging. So the purpose of this fellow exchange between the Côte University and Politehnica University of Bucharest was to develop a new method for multimedia network control, which was based on column generation algorithm and graph neural networks. Also, the exchange aimed at creating new collaboration opportunities between the two institutions. And of course, we are very glad to confess that we continue remotely our work, and we have weekly meetings each Friday. I will talk also a bit about the compliance with the AI for Media objectives. We have targeted the outcome 4, which talked about the toolkit with new content-centric AI algorithms and applications. And also AI for Media project through use case 3 envisions the high quality video production and content automation, which is also reflected in our research. So we target situations involving video capturing using mobile phones and high-speed mobile networks, where we need a high quality of broadcast experience. We looked at some video content features that influence the resource allocation process, as encoding rate, resolution popularity, and some others. And also, starting from the literature and from the results in the literature, we saw that the machine learning-based techniques with respect to the classical optimization techniques are very useful to classify the content based on these features, and also on the relationships to many constraints of the network. As objectives, we aim to develop an optimal control method for multimedia networks, which was based on column generation algorithm and also on graph neural networks. Also, we wanted to adapt the network control methods to the video content features, and to increase the quality of experience in multimedia networks. In addition, we identified and we aimed at identifying an existing data set, but unfortunately, we didn't find such data set. But we created an artificial one which is as realistic as possible for testing the proposed method. And of course, we established collaborations between the partners. Now, concerning the outcomes, first of all, I wanted to present the activities and tasks in which I was involved. Of course, this study was started from the beginning. I mean, I was not involved in this kind of activities before, but it was very challenging and also very motivating for me to meet the supervisors and to formulate the first version of the optimization problem and to follow all the guidelines to get familiar with all new concepts. I have also received some prerequisite materials that I have followed. After that, I had to cope with the combinatorial optimization algorithms, and also with graph embedding methods for and also with GNN. I had to cover many new topics for me, like representational learning on graphs and deep neural graph representation. And also I have followed many implementation proposed in the literature. And finally, after several discussions I had with my host supervisor, we reached the final formulation of the optimization problem. We have here on the proposed workflow. So we had a video content catalog that has each video content has some features. We have also the bitrate, the resolution of the video content. We have the number of users that require that content, and also the transcoding cost for each video content. We have a power model and the network topology, and also based on all of this input, we implemented the restricted master problem in Cplex. And following the output of the Cplex report, we create another data set based on the variable coefficients, on the slackness and tightness parameters, and also on upper bound and lower bound limits of the constraints. Following the output of the Cplex report and on the data set we create based on this report, and using the graph convolutional networks, we try to solve the pricing problem. After that, a new version of the video content catalog is retrieved, and if a stop criterion is fulfilled, then we can use further Cplex to solve the original mixed integer linear programming. Or if not, then we have to solve again the restricted master problem until we reach the optimum video content catalog. Other activities, of course, involve the implementation of the optimization problem using IBM iLog Cplex linear optimization program. I had to study the literature to identify the dataset, but as I told you, there is no such data set, and I had to create an artificial one. After that, I had to deepen the graph neural network part to solve the pricing problem. And I have studied and implemented different architectures, and I work with the spectral library. Also, I have participated in several events, such as Core Numeric, where I attended the presentations from the European project In Your Heart, involving the artificial intelligence, the digital simulation, and cardiology experts that discussed the impact of digital transformation and AI in diagnosis. And also, I participated to the statistical learning theory for modern machine learning colloquium at IRIA. Other activities, of course, I had to create weekly reports to track the exchange's progress, and I'm very satisfied with this kind of, let's say, work tracking. because it motivates and helps very much to go further with the work, especially when the topic is so new and challenging. And also, I created the GitHub repository where all the code is stored and where versioning is possible. Currently, they are available only for the Université Côte supervisors, and also the report where we integrated the results are currently available only to the supervisors. As next activities, because as I told you, 2 months it was not enough for such a challenging problem. But the next activities I worked on during, let's say, the continuation of the physical exchange, but this time remotely. So this next activities involves the CPLEX dataset creation. I mean, the one based on the CPLEX report I have mentioned here. And also creating or implementing, in fact, the appropriate graph neural networks using the dataset created at NA1, and also to integrate NA1 and NA2 in along with the column generation implementation, and after that to do the extensive testing. Here are some general outcomes. So we have succeeded in formulating and implementing a variant of the resource allocation optimization in order to increase the quality of experience. And also, I have generated the artificial data set as realistic as possible. And when I'm saying that it's as realistic as possible, I'm referring here that I have used previous validated research, the probabilities of the number of users in fixed and mobile networks, the probabilities of resolutions requested by users, some laws of video content distribution, bit rates, specific for some types of video contents, for example, sport, movie, or cartoon. And also, I have established many collaborations with colleagues, and also with my supervisors. And as specific results, we have the publication and software part. Concerning the publication, the work is still in progress, and of course, following the validation of the developed architecture, we will publish also work. This is estimated for February 2023. Concerning the software, as I told you, I have created a GitHub repository to keep track of my implementation part. Here we have the part where the optimization problem was defined. Also, the part where the artificial data set is generated, where the CPLEX solutions are also generated. As other materials, I have the weekly work progress reports. You have here the link where you can access them. And also the technical report that is currently presenting the context and optimization objective, and also the envisioned architecture, and also the objective function and constraints. As other information, the travel was, in fact, the exchange took place in Sofia Antipolis at Centre National de Recherche Scientifique, and it has a duration of almost 2 months. Also, here is the travel information table. Also, our university had to support, let's say, more funding for the travel expenses, and Université Côte d'Azur supported the accommodation expenses. Here is the group photo, and I thank also to my colleagues. Also here, I have my colleague, my office colleague, Quentin Guimard. So nice to meet him again. And here's some photos with my colleagues, and here is also Professor Javier Decomp. And of course, I I was very pleased to meet such a nice environment and nice people. And the greatest joy, let's say, is that we continue to work together. So thank you for your attention.